transport layer in Java remote method invocation. Transport layer. The bottom layer is the transport layer, which is based on TCP IP connections between machines in a network. It provides basic connectivity as well as some firewall penetration strategies. Here you can see the unfettered use of TCP IP connections between JVMs. Here you can see the transport layer makes the connection between JVMs. All connections are stream-based network connections that use TCP IP. Even if two JVMs are running in the same physical computer, they connect through their host computer's TCP IP network protocol stack. This is why you must have an operational TCP IP configuration on your computer to run JVMs. And this diagram shows the unfettered use of TCP IP connections between JVM. As you know, TCP IP provide the persistent stream-based connection between two machines based on an IP address and port number at each end. Usually DNS is used instead of IP address, which means you could talk about TCP IP connections in the current release of RMI. TCP connections are used as the foundation for all machine-to-machine connections. On top of TCP IP, RMI uses wire level protocol called Java Remote Method Protocol, JRMP. JRMP is a proprietary stream-based protocol that is only partially specified, is now in two versions. First version was released with Java 1.1 version of RMI and required to use skeleton classes on the server. The second version was released with the Java 2 SDK. It has been optimized for performance and does not require skeleton classes. There are versions like RMI IIOP, which is available in Java 2 SDK version 1.3. RMI transport layer is designed to make connection between client and server even in the face of network obstacles. While the transport layer prefers to use multiple TCP IP connections, some network configuration only allow a single TCP IP connection between a client and server. Some browsers restrict applets to a single network connection back to their hosting server. So here you can see JRE there, and host OSs are there. These are connected through the network layer, and also this JRE and remote JRE is connected with the different host OS through the network layer. As a separate description, on top of TCP IP layer, RMI uses wire level protocol called Java Remote Method Protocol, JRMP, which work like this. Now, step 1, object that require remote behavior should extend the remote object class, typically through unicast remote object subclass. The unicast remote object subclass exports the remote object to make it available for serving incoming RMI calls. Exporting the remote object creates a new server socket which is bound to a port number. A thread is also created that listens for a connection on that socket. The server is registered with the registry. The client obtains details of connecting to the server from the registry. Using information from the registry, which includes the hostname and port details of the server's listening socket, and client connects to the server. When the client issues a remote method invocation to the server, it creates the TCP/IP connection object, which open a socket to the server on the port specified and send RMI header information and marshaled argument through this connection using the stream remote call class. On the server side, when the client connects to the server socket, new thread is assigned to the deal with the incoming call. Original thread can continue listening to the original socket so that additional calls from other clients can be made. A server reads the header information and creates remote call object of its own to deal with unmarshalling RMI arguments from the socket. The service call method in the transport class services the incoming call by dispatching it. The dispatch method calls the appropriate method on the object and pushes the result back down to the wire. If the server object throws an exception, server catches it and marshals it down to the wire instead of returning the value. And back on this client side, the return value of the RMI is unmarshaled and returned from stub back to the client code itself. If the exception is thrown from the server, that is unmarshaled and thrown from the stub. As an example, we can consider stream remote call. The class stream remote call, stream based implementation of the remote call interface. This is in package sun.rmi.transport. As an exception example, we can consider IO exception. This is IO exception for any other problems with IO in method object output get result stream boolean in class stream remote call. As an example too, we can consider this sample code illustrating a secure RMI connection. This is basically modified to install and use custom RMI socket factory. It uses RMI over SSL transport layer. Factory and SSL here using JSSCE. Here interface RMI socket, RMI client socket factory. An RMI client socket factory instance is used by the RMI runtime in order to obtain client sockets for RMI calls. A remote object can be associated with an RMI client socket factory when it is created or exported via the constructors or export object methods of java.rmi.server.unicast remote object and java.rmi.activation.activatable activatable. In RMI, the interface RMI server socket factory. An RMI server socket factory instance is used by RMI runtime in order to obtain server sockets for RMI calls. A RMI object can be associated with an RMI socket factory when it is created, exported via the constructed or export object methods of java.rmi.server.unicast remote object and java.rmi.activation activatable object. These are in java.rmi.server package. Here you can see make reference to SSL based registry in local registry.get registry, and here you can see a new RMI SSL client socket factory is there for SSL. As an exception example 2, we can consider IO exception. If an IO error occurs during socket creation in create sockets string int method in interface RMI client socket factory. And as an example 3, we can consider this sun.rmi property, sun.rmi.transport.tcp.read timeout. This value of the value of this property represents the time in milliseconds used as an idle time for creating TCP/IP connections the Java RMI runtime uses. The value is passed to java.net.socket.set so timeout. This property is used only for cases where a client has not dropped an unusual connection as it should in sun.rmi properties. The default value is 2 multiplied by 3600 multiplied by 1000 milliseconds, that is 2 hours. Now we are considering RMI transport protocol. The wire format for the content of the transport header are not formatted using object serialization. The wire format for RMI is represented by a stream. The terminology adopted here reflects a client perspective. Out refers to the output messages and in refers to input messages. The content of the transport header are not formatted using object serialization. The input and output streams used by RMI are paired. Each out stream has corresponding in stream. The out stream and out stream in the grammar maps to the output stream of a socket from the client perspective. In an in stream in the grammar is paired with the corresponding socket input stream. Since output and input streams are paired, the only header information needed on an input stream is an acknowledgement as to whether the protocol is understood. Other header information such as the magic number and version number can be implied by the context of stream pairing. Now we are considering format of an output stream. Alternatively, an output stream can contain an invocation embedded in the HTTP protocol. An output stream in RMI consists of transport header information followed by a sequence messages. Alternatively, an output stream can contain an invocation embedded in the HTTP protocol. The messages are wrapped within a particular protocol as specified by protocol. For the single op protocol, there may only be one message after the header, and there is no additional data that message is wrapped in. The single op protocol is used for invocation embedded in HTTP request where interaction beyond a single request and response is not possible. For the stream protocol and the multiplex protocol, The server must respond within a byte 0x4e, acknowledging support, for the protocol, and the endpoint identifier that contains the hostname and port number. That server can see is being used by the client. The client can use this information to determine its host name and name it if it is otherwise unable to do that for the security reasons. Client must then respond with another endpoint identifier that contains the client default endpoint for accepting connections. This can be used by the server in the multiplex protocol case to identify the client. For the stream protocol, after this endpoint negotiation, the message are sent over the output stream without any additional wrapping of the data. For the multiplex protocol, the socket connection is used as a concrete connection for the multiplex connection. Virtual connections initiated over this multiplex connection consist of a series of message as described below here. There are three types of output messages: call, ping, and DGC ACK. A call encodes a method invocation. Ping is a transport level message for testing liveness of remote virtual machine. DGC ACK is an acknowledgement directed to the server's distributed garbage collector that indicates the remote object in a return value from the server have been received by the client. Now we are considering format of an input stream. A ping ACK is the acknowledgement for ping message. There are currently three types of input messages: return data, HTTP return, and ping ACK. The return data is the result of a normal RMI call. HTTP return is return result from an invocation embedded in HTTP protocol. Ping ACK is the acknowledgement for ping message. As an example 7, we can consider interface endpoint. This is in the package sun.rmi.transport. Now we are considering interface channel. This is in the package sun.rmi.transport. Now we are considering class TCP endpoint. TCP endpoint represents some communication endpoint for an address. This is in the package sun.rmi.transport.tcp. Now we are considering a TCP class TCP channel. TCP channel is a socket-based implementation of the RMI channel abstraction. This is the package sun.rmi.transport.tcp. Now we are considering class TCP connection. This is in the package sun.rmi.transport.tcp. Now we are considering class TCP transport. TCP transport is a socket-based implementation of the RMI transport abstraction. This is in the package sun.rmi.transport.tcp. Now we are considering properties that can be stored on, can be set on RMID in sun.rmi properties. sun.rmi.transport.tcp.localhostname timeout. The value of this property represents the time in milliseconds that the Java RMI runtime will wait to obtain a fully qualified domain name for the local host. The default value is 10,000 milliseconds, 10 seconds. Now we are considering properties that are useful to set on VMs that make remote method calls. sun.rmi.transport.connection.timeout. The value of this property represents the period in milliseconds for which the socket connection may reside in an unused state before the Java RMI runtime will allow those connections to be freed, closed. The default value is 15,000 milliseconds, 15 seconds. Now we are considering Java RMI's implementation logging. System property name here sun.rmi.transport.loglevel. Logger name sun.rmi.transport.misc. Information logged, transport layer activity. Want thread pooling at RMI transport layer enabled by default. As a local fix, we can consider customer can set it, and with the property sun.rmi.transport.tcp.no connection pool equal true or any non value to disable thread pooling.